So good evening. Let's start the session. So basically, yesterday we went through some of the data processing, and we will continue on the data processing and some of the evident libraries which helps us to do data processing in Python. So let me start sharing my screen. Okay. So we did go through the pandas activity yesterday. Now, if you see the next particular library, which helps you to do lot of data interpretation, which helps you in resulting about data transformation, is your NumPy. Now, if I ask you a very simple question, how many of you like playing Rubik's Cube? Just put it on the chat window. How many of you like playing a Rubik's Cube? Okay, so we have one person, Sridhar says. Anybody else? Okay. Now, how many of you feel that solving a Rubik's Cube for all colors is more difficult than solving a Rubik's Cube for a single color? How many of you feel that? Anybody who thinks that solving all colors is difficult than solving a single color of Rubik's Cube? Nobody? Any more answers? Okay. So the whole intent of me asking you this question is basically the entire Rubik's Cube is based on one phenomenon, which is your matrix calculations. The more familiar, I don't even call stronger, I call it familiar with your matrix calculations, that easy it is for you to solve a Rubik's Cube. Because a Rubik's Cube, if I happen to show you so that we understand the things. A Rubik's Cube is a simple collection of metrics, which means you have either a 2 cross 2, 3 cross 3, whatever we call. That is what, if you see this particular thing, see, this is a Rubik's Cube, right? So this is the 3 rows, row 1, row 2, row 3, column 1, column 2, column 3. Similarly, here it is row 1, row 2, row 3, column 1, column 2, column 3. Which means what you are trying to do or solve internally is you are trying to solve the your matrix computations. That is how the positioning of your color comes in, right? If you see this particular thing, this is your simple matrix: row 1, row 2, row 3, row 4, column 1, column 2, column 3, column 4. If you see all your data, whichever is structured, wherever you have a database in Excel or you have it in a database, all of these are divided into rows and columns. You have your rows, you have your columns. So the moment you have the data in rows and columns, understanding your matrices becomes very, very, very important. There will be need to combine the data, there will be need to transform the data, there will be a need to dissect the data, deject the data, all of this. So to do that activity, if you happen to write a Python code, you would require a lot of effort, because you should understand the way matrix works. Then you will have to put your assumptions on that to get your details, while NumPy does that very, very, very easily. So like pandas, NumPy is one other well established, very strong library. So if you see this matrix, the internally it is stored with an id. So if you see a of 0 comma 0, this is a 0 index, 1 index, 2 index, 0th index, 1 index, 2 index, 3 index. Therefore 0 comma 0 is telling me row 0 column 0, 0 comma 1 is telling me row 0 column 1, row 0 column 2. This is telling me row 3 column 0. This is telling me row 3 and column 2. Therefore it internally stores and helps you to do multiple multidimensional activities using NumPy. So if I happen to show some simple functionality of how NumPy is working, let me take that. Okay. So if I happen to come here, let me also insert one simple thing. Now, if I see this particular simple code, I have my NumPy as NP. I have defined a simple matrix which we call also as an array. So here NumPy.array, I am defining a matrix which has 2 rows, 3 columns. So if I go ahead and see my matrix and see the shape, it will tell me 2 cross 3. Therefore, if you see this particular thing, it is giving me my matrix and it is trying to give me my shape of this matrix. So if I can always see what is the shape. So if I go ahead and give one other array, now if you see, it will give me 3 cross 3 matrix. So it is 3 rows, 3 columns. Previously it was 2 rows, 3 columns. So basically you converted a simple list into a matrix. Here NumPy can also work very well with your Python built functions. The tight integration, even though a NumPy is also a library, it works well with the inbuilt functions of Python. That becomes like how we saw in pandas. Here also it works. So if you see this simple code, what we have done here is we have a simple array, whatever I defined on the top. I am using the max function. So the maximum value in this, it will see what is the maximum value in the entire array or the matrix and tells me it is 4. If you see, the minimum value is 1. If I use the sum, it is telling me the sum is the total of all of the values, whatever it could be, 10, 11. And if you happen to see, it is 15. Then if you happen to see, you can also do the summation at the row level and the column level. So to do the row level or at the column level, I use the axis 0 or axis 1. So when I run this particular thing, basically, if you see this particular, this is my original matrix. This is my shape, which is 2, 3. The maximum value is 4, minimum value is 1, the sum is 15. And if you see 3, 5, 7. So 2 plus 1 is 3, 3 plus 2 is 5, 4 plus 3 is 7. That is what I am getting here. There, whereas if I add 1 plus 2 plus 3 is 6, 2 plus 3 plus 4 is 9. I get it here. So a row wise addition or a column wise addition is also a possibility within your NumPy. Similarly, if you happen to see, let me show you some of the functions which are statistically important, like your variance, square root, standard deviation, mathematical addition, mathematical division, simple high school matrix activities NumPy can do with ease. So if you see this particular thing, all that I have done is I have defined 2 arrays. Now, even without seeing, I can say this is 3 rows, 4 columns, which is my first array, which is A. My second array is also of the same dimension. Now, on my first array, if I use the square root function, np dot square root, it is giving me the square root of each and every value in the matrix. Similarly, on the same matrix, if I use the standard deviation function, std is the function name. Here sqrt is the function name. Here I have the std function on A. If I go ahead and run this, I get this values. Now, if I take this as a simple arrays or matrix and I do an arithmetical addition, I get the simple addition, which is A plus B, 2 plus whatever individual values you add. You can do the multiplication, division, whatever you want to do on your matrices with a simple command. Mathematical operations on your matrices are allowed easily. Then, if you happen to see there during the transformation in our pandas yesterday, we saw there will be a requirement where we might have to merge, we might have to do an horizontal folding, vertical folding, unfolding. For that, you have something called as H stack and V stack. So what is horizontal stacking or H stack? Now, let me show you what is my A and B. Now, if I see this, my A is, okay, let me print separately so that you can see one below other. Otherwise, you will see and get confused. Okay. Now, if you see this particular thing, my value A is 1, 2, 3, 4, this one, which is my 3 cross 4 matrix, which it is showing me here. Now, I have the same thing for my B, which is again 3 cross 4. Now, what I did was I used an H stack functionality. What does H stack functionality do? An H stack functionality merges it at the column level. So if you see this 1, 2, 3, 4, 3, 4, 5, 5, 1, 2, 3, 5 from my first thing has come here. Okay, 1, 2, 3, 4, 3, 5, 5, 5, 1, 2, 3, 5. From my second matrix, it has concatenated at the row level. Therefore, the shape of the concatenated one became 3 rows, 8 columns. Right? I did not have to really do much, but using a simple function h stack, right, I got my shape changed to the shape post concatenation. Similar to this particular thing, if I happen to do a V stack, the 1 2 3 4 3 4 5 5 1 2 3 5, this both of them will get converted vertically. So if I run this particular thing, actually I have already run, you saw this. So if you see the vertical stack, I have my A, B, it was 3 cross 4, 3 cross 4. When I add up at the row level, the rows get added up at 6, the columns remain the same. Therefore, it became a 6 row, 4 column in matrix. Therefore, it is 6 cross 4 matrix. So the H stack, V stack are very, very important, because especially when you are getting the data from multiple places. Imagine it's the same data you are getting from multiple places, and you need to keep on stacking it up. There, you don't have to really do any more things. You can use your H stack, V stack, add, keep adding this. In case you want to transform, this is a 6 cross 4 matrix. You want to convert this, or this is a 3 cross 4 matrix. Your A is a 3 cross 4 matrix. You want to convert this into 1 row, 12 columns. You have a simple function called as ravel. If you see this, ravel is a simple function which helps you to do all these particular things quite easily. So what ravel does, if I go ahead and run this particular thing, my A is 3 cross 4. So if I go ahead and say print A dot shape, okay, so it is a 3 cross 4 matrix. My 3 cross 4 matrix got converted into 1 cross 12. Right? So what was 3 cross 4 became a 1 cross 12 easily. So that is how you use the ravel. So basically H stack, V stack, and your ravel are functions like pandas. Like pandas, NumPy also has a number of functions. There are more than 100 plus functions in NumPy, and with every version, the number of functions in NumPy keeps adding. But what is very important is, for us, we should keep a tab on what are the various functions which are available in any library. That way we can get to see or leverage the things relatively easy. This is your ravel. The next one is about how exactly we can slice the data, right, using a combination of things, where you are using certain functions of your Python, at the same time you are using certain functions of your NumPy, and trying to do the things. So if you see this particular thing, I have a range function. How do we have a range function in Python? We have an a range function in NumPy, where you have 3 values or attributes which you can pass: a minimum value attribute, maximum value attribute, and an interval value attribute. Now, if you see this, A is equal to NumPy of arrange, 0 being my initial value, 100 being my maximum value, with an interval 5. When I print A, I get 0, 5, 10, 15 till 95. Always it is n minus 1. My maximum value is 100. Therefore, one value previous to that is what I get, 95 I got. Now, I use one other function from Python, which is a slice function. What I am doing here is, I am defining a variable, yes, use a slice function. I am saying in the slice, start from 2, go all the way. This is the index value. Start from index value 2, go to an index value 15 with an interval 3. Okay, here the difference is, in A range, you use the value. In slice, you use the index value. Now, when I say print yes or print A of yes, so print yes is telling me it is a slice because yes is this. But when I say print A of this slice, see this particular thing. In this, this is 0 index, this is 1, this is 2, this is 3, this is 4. We know the index values. Therefore, when I say start from second index, my second index is 0, 1 and 2. Therefore, 10 is my first value. After 10, I am saying skip by 3 index values. Therefore, 10, 15 it did not put, 20 it did not put, 25 it put. If I don't give the index value as anything, the skipping I don't give, from 2 to 15, it will go ahead and put every value inside this. So this, if you see 10, 15, 20, 25, it put. But if I put here 2, it will step by 2 to index values. So if you see 10, 20, 10, 2 digits, 30, 40, it is putting this way. So whatever the index values we have, that you can use it relatively easy and get doing. This is on breaking the whole thing, right? Similar to this, if I happen to show you this, now this particular thing, if you go ahead and see, all that I have done is the same. I have my A range to 10. So when I give only one value, it will take as the maximum value. It will consider 0 as the minimal value. Therefore, 0 to 10 with one interval is what it takes. Therefore, when I printed A, it becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I introduce one other variable B is equal to, I say A, and within my parenthesis square brackets, I try to put the index values. Now I am saying give index value 2 to 9 in the steps of 2. If you go here, it will come the same thing. So if you see my first index 2, which is 0, 1 and 2, therefore 2 till 9, in the step of 2, you get it. The only difference between this and my previous run, this here I am using a slice function, which is an inbuilt function. Here I am using the index breaking option. Both work with NumPy. So I'm using NumPy to create a matrix and using the Python approach of either using a Python built-in function like slice or Python index approach and dividing the data. It is a subset. Now, whatever I have B is a subset of my A, right? So that is how I got the data. Now, if I want to slice the data here, like how I gave 2 colon 9 2, if I say only 5 colon or 2 colon after this index number, whatever are the values, you get it. So if you see 5, 0, 1, 2, 3, 4, 5, 5 is my first index. After 5, whatever I had, I got all the values. This way, what I am trying to do is whatever the values which are relevant with regard to this are coming. The next, if you happen to see, now if I want to slice the data at a row level, column level, index level, you can do it. Now, in this case, take this simple array. I have a 3 cross 4, 3 rows, sorry, 3 rows, 3 columns. This is a 3 cross 3 array, which is a square array or a square matrix. In this, all that I want is the second column, the second row, and excluding the first column, I need everything. If that is my intent, I use this dot approach, which is specified by NumPy. Now, if I want to use only second column, see this. This is my matrix. What is the second column? 2, 4, 5 is my second column. I get the value 2, 4, 5. If I need the second row, it is 3, 4, 5. I get 3, 4, 5. I want all the columns excluding the first column, which is 1, 3, 4. If you see here, I get 2, 4, 5, 3, 5, 6, which is excluding the first column. That way, we happen to see NumPy helps you to do data transformation significantly easy. And you don't have to really worry about how exactly, what exactly, but you have to know what are all the functions which are available, how to leverage which functions at what stage. That is something which is on NumPy. At the same time, if you happen to see the third big library, which is very, very powerful, very, very useful, is your matplotlib, which is a plotting library, which means it will help you to generate various kinds of graphs. It could be a simple bar graph, an histogram, a scatter plot, hexagonal bin plot, pie plot, you name it, you have it. So that way you are trying to get the benefits of Python getting you to use this for your graph generation. So if I happen to show you few examples of how exactly you use whatever the transformed data using your NumPy or pandas into your visualization. See this. Here I am using a matplot library. From matplot I am importing pyplot. So I assume all of you know you can use import matplot, or if you want only specific some of the libraries only, some of the modules only from a library, you can use this. This is helping you to become more and more memory resourceful. You don't have to import the entire matplotlib, which has so many modules, so many functions. If you are not using, you are using, consuming your memory for no use. Therefore we use this approach. I'm saying only get me pyplot. Now if you see this particular thing, plt.plot, I just gave my x and y coordinates and I used the plot plt.show. If I see for the first coordinate 1 comma 4, so for my x coordinate of 1, my y coordinate is 4. For x coordinate of 2, I have the y coordinate of 5. X coordinate of 3, I have the y coordinate of 1. Therefore this plots. Now if I change this to 11, see this. Okay, this is running. Okay, this is executing. I just had this thing. So what was 3 1 became a graph inverse now. Now because my y coordinate is 11, my x coordinate is 3, it went like this, right? So this is a simple line graph. For this line graph, if you want to add your x-axis, y-axis, all of this, you use the titles. So basically, if you see the title, I have said it is an info. So therefore, I see it as info. I named my x label as x-axis, y label as y-axis. I just showed it. But if you happen to see, if you want to plot more than one graph, more than one straight line on a graph, you can use the same thing. So you have some styling options. So I use the style ggplot as my styling option, and I give my x coordinates, y coordinates, x1 coordinates and y2 coordinates, and I plot the two graphs. Basically, I have my same x and y axis, but my x and y and x1 and y1 values are different. So I am plotting this like any other thing, the title, label, legend, all of this I have put. So the legend will give you details of the colors. So here I have given the grid color as K, therefore K is black. If I want red, I give R. So if you see R, and green is G. Now for my first plot it was green, for my second plot it was red. Therefore for the epic info I get like this. For my x1 coordinates, y1 coordinates, or whatever you have, you get to see the things. That is your simple line graph, multi-simple line graph. Similarly, the most famous graph what we all have studied or all have seen is your bar graph. So for every x and y coordinates, you have a simple bar graph. This is your x, this is your y. Therefore, if you happen to see, I have my x and y coordinates. I am plotting 1, 3, 5, 7, 5, 2, 7, whatever this. I give it the explanation as example 1. Therefore, it is telling me example 1. Here, I did not specify the color. It randomly choose. In my second bar, I explicitly said green. So, it plotted in green. So, that is how you go ahead and run this particular thing. You get to see that plot graph. So, one good thing, if you give this color, always that color will come. If you don't give randomly choose, if you see my previous run had taken red, this run has taken blue. If I rerun again, this might be the same color or it might be a different color. Let's see. So if you see it gave the same blue. But if I mention the color, here I say COLOR is equal to R. Now always it will be red and green. So it will always be red or red and green because R I have given and G I have given. So that is the way what you try to do this particular thing. Now, if you see the histogram, so we know a histogram is a graph where we have various buckets. Basically, if you see this, what I have done is I have a data which is a population, ages. People, the total number of people who are there, their ages individually. I have one list here. I have created a bin 0 to 50, 50 to 100, 100 to 130 is my 3 bins or 4 bins. If you see this, my entire data, what is here, it has divided into 3 bins and it is telling me how between 0 to 50 years, how many people are there, 50 to 100 years, how many are there, 100 to 130, how many are there. I can go ahead and change the bin size. I can make bin of 10, bin of 40, bin of 100, whatever based on my data spread I can use. And in the histogram for the width, you can do that adjustment. So my width is 0.8, therefore this is coming as that. And I am saying my histogram, there are various types. I use the bar histogram. This is on a simple histogram. Similarly, if you happen to see a scatter plot. What is a scatter plot? Anything where we spread the data for every x coordinate. If you have the associated y coordinate is your scatter plot. So I have my x, y values. I use a simple plot scatter. And I use this. If you see this, this is a simple scatter plot. So I don't have to do anything relatively. I use a simple scatter and I get it. And I know more, we saw scatter plot when we were using the regression approaches, when we were using the k-means approaches. All this we use the same scatter plot. Then the stack plot. What is the stack plot? If you want to stack multiple values and show it in a simple graph, you can do a scatter stack graph. So if you see this particular thing, what I have done is in a span of 24 hours in a day, what is that we do? I have tried to divide my things into 4 things: sleeping, eating, working, playing. If you take this particular things, this is what my scatter plot, stack plot looks like. So this is my y coordinates, this is my x coordinates where I have the time. So if you see the day 1, this is the whatever the time I had put 8 hours. So if you see 7 to 7, 8, right? So 0 to 7 hours I do sleeping, 7 to 9, which is 2 hours I do eating, then between 9 to 15 hours, which is again 7 hours I do working, and again 7 hours of playing. So that is how it stacked the whole data and it shows it. So if you see, the second values are different, the third values are different, fourth values are different. Therefore it is also giving you the color indication. The lavender is sleeping, the green is eating, the red is working, black is playing. So that gives you a comparative spread of data. You can always infer day 1 you had a lesser playing, while day 4 you had more playing. Day 1 you had more working, day 4 you had very less working. While with regard to sleeping, you did not compromise a lot, rather you increased it, while in the eating time it was more or less the same. So those kind of inference from a large data can be drawn using your stack plot, because data transformation is all about trying in between and revisiting. So I will always compare this to a cooking. So when you're cooking a new dish for the first time, many a times you try to taste to see if you are in the right direction. Data transformation is also the same approach. You just cannot switch on something and say, yes, the data is transformed. That does not work that way. It's a journey. You will have to do that particular thing. Pie chart, I don't have to talk too much about pie chart. All of us know pie chart. We have been using pie chart from our middle school or primary school. So if you see this particular thing, this is a 360-degree graph where I have my data split. But there are various attributes to be split. So I can use the slices with the activities. So I have a playing, eating, sleeping activities. If I want, I can give the colors. So whatever color I want for each of them, I can define. So I have defined here my sleeping as M, eating as C. So therefore it has taken that colors. Then I can say my pie chart has to start from a 90-degree angle or a 180-degree angle or a 270-degree angle. This is the start angle. Yes, start angle. This is the start angle. Then if you want to see a shadow, what you are seeing here, you can say shadow as true. And if you want to slice it as a pizza, you can use the explode function. So other than the third coordinate, second and third coordinate, I have not done an explode. For all others I kept 0. Therefore it is like this. So imagine I put 0.2, 0.4. Now if you see, the explode will be quite far, right? So that way you can use the explode function and do the things. Now if you see, it exploded completely. This is the explode, and auto percentage gives you the percentage fill. It says playing is 54%, sleeping is 29%, eating is 8%, working is 8%. So it gave you a relative percentage internally. So that way you have the various graphs which are available for you to do, and you can do it things really easily. So that was on your visualization. These 3 libraries from a data processing standpoint becomes very important. There are few more libraries which we will see. So if you see, the next one is the Selenium library. This predominantly from a data transformation standpoint might not be very useful, but from an automation standpoint, it is very useful when you are trying to integrate with some web-based browsers. All right. So Selenium is a testing tool by itself. Python has a library called as py selenium, and you can use that SE library and you can do the integration. This is also works very well when you have to extract the data from the web, especially when you have to do the web scraping for various controlling. You can use the Selenium library to scrape the data, feed the data, and transfer the data. Then comes the OpenCV. We saw the OpenCV the other day. So where we said to do all your visualization, especially we use OpenCV. So we read the other day, or we saw the other day, how does it work is, basically it tries to get the pixel coordinates, which it feeds into your NumPy. NumPy gives you the coordinates, the matrix coordinates. That is how we use our OpenCV. The OpenCV is a library which helps you to process your images very, very, very well. But of late, OpenCV is also helping you to do some text transformation, which is very, very limited in nature. But OpenCV more is used for your image processing. Then comes your SciPy. So it is again a scientific computing and technical computing library. So especially to do large scale computing, nothing to do with machine learning, nothing to do with your image processing, but more to do with your computation. You try to use your SCI Pi or SciPy, what we call. So SciPy gels very well with your NumPy, and then it integrates with all your other libraries like your Matplotlib, Pandas, all of them in this particular thing. So that is what happens in your SciPy. The next one is basically the scikit-learn. The scikit-learn, like we have seen in our machine learning section, we use scikit-learn or SCIKIT learn library for all our machine learning. It has the classification, clustering, regression, all approaches, whatever we see, it has the things to do whole. So that particular thing, it will tell you and how exactly you can use scikit learn. The next one is the PySpark. So this is the API based integration for your Python. So you might use the API where to integrate the data for feed forward or feed backward, which means either to extract the data or push the data. You use the PySpark. Basically, you are combining the Spark functionality with Python is what you happen to do the things. Now, if you happen to see the next library, it is Django, which is again the data what you churn. If you want to publish back to a browser, we use Django. So it is again an MVC based library which works with your browsers. So basically, to feed the data out of your Python onto a browser, you use Django. Next but not the least is your TensorFlow. So for all our deep learning approaches, we use TensorFlow. So TensorFlow is a library which is built by Google. So it works on multi-dimensional data flow approach. So here what happens is, it converts the data into something what we call as tensors. And this particular thing, you get whatever we see, that the data you get to push and get it. So a TensorFlow is one of the highly adapted libraries within Python. So this way, the whole transformation of data using some of the basic Python activities and some of the complex Python libraries like your TensorFlow or Matplotlib or your Spark, you happen to do various things. This gives us that required leverage in terms of how we do and what we do and where exactly we use the whole thing. So this is our various activities in terms of the uh, data processing. So what we will do now is basically we will also go ahead and see how exactly we can transform the data what we see when the data is more overlapping. For that particular thing, we will try to talk today about one other approach which we call it as CNNR, convolutional neural network. So that is a very very interesting pointer, and let's see how exactly it will help us to do things relatively easy. Okay. So today, one thing also what I wanted to say is that today we will not have a full long session. Probably in another 15-20 minutes we will close the session. You will also get the attendance link, but we will start our activity with understanding some sample, or rather an introduction to the convolutional neural network, and we will try to do the working of this in our next session. So if I have to revisit what we spoke in our approach of computer vision, we see this particular thing. Basically, a computer, how a computer reads an image is through pixels, and we say the RGB values are very important. Red, green, blue values are very important. And if it is a grayscale, we get to see two frames. If it is colored, we get to see the three scales. That is how the size of the image becomes the b into a into 3. Therefore, if it is a grayscale, it is b into a. If it is the colored image, the same thing becomes the r, g and b, the three colors which gets into consideration, and therefore the three layers data comes into place, the RGB values. Now, with all this in mind, with all this in mind, let's go ahead and see how exactly are the need for one other approach when we already had an artificial neural network, right? So if you remember, when we were talking about artificial neural network, we said every neuron connects to its preceding neuron fully. There was an interconnectivity between all of them. So if you see, this was our simple understanding of our neuron or a neural network. So this was our input layer. This neuron is connected fully from this to this. So this one neuron, 1 2 3 4 5 6, there are 6 neurons in my center layer, or the first hidden layer. Therefore, from this neuron, this is connected to all the 6 neurons here. Same way happens from here to all the 6. Same way happens from here to all the 6. Interestingly, from my second layer to third layer, this happens the same. Here I have 1 2 3 4 5 6 7. Therefore, this neuron again connects to all my 7, and this neuron connects to all my 7, and that repeats. This neuron connects to all 7, this neuron connects to all 6, this neuron connects all 5. Therefore, if you happen to see, I have an image which is just 28 megapixel, not 28 megapixel, 28 pixel by 28 pixel, and being a colored image, imagine the number of weights in the first hidden layer. If you see, 28 into 28 into 3, because it is a colored image, it will have 3 layers. Therefore, the number of weights what fall on the first hidden layer will be 28 into 28 into 3, which is 2352. And you know how small a 28 pixel by 28 pixel photo will be. A very, very, very small photo. Imagine I make it little big, a 28 pixel to 200 pixel. Now 200 into 200, 2000 pixel is 2 megapixel. Imagine. I'm giving you the relative things. A 2 megapixel camera was something 5-10 years back what you were using on your mobile phone. Probably today most of the mobile phone have 5 megapixel and above, and many of them have baseline 13 or 14 megapixel. Now I am talking about 200 pixel, not even 200 megapixel. 200 pixel. See the weight in your first layer. 200 into 200 into 3, which is 1,20,000 weights when it comes to the first layer, which means the amount of computation it has to do will be incrementally, or rather I would not use the word incremental, I will use the word exponentially high. Imagine in this case the third layer, the second hidden layer or the third layer from the input is only 7 neurons. There are 15 neurons. Then the number goes infinitely higher. So that way it becomes 1,20,000 things. So guys, give me a second, 1 second. So when you have such large images, using a fully connected network requires a large amount of computation. And we already spoke, I don't know, I don't remember, but I'll always again ask you, by any chance anybody knows what is the human eye megapixel capabilities? You have all your mobile phones, everything, so what is the human eye megapixel capacity? Anybody? Human eye megapixel. So any of you are already googling it? What is the human eye megapixel? Nobody? I don't see anybody answering it on the chat window. Yeah, 576 megapixel, right? The best of the best camera today, the best of the best mobile phone cameras today have not more than 100 megapixel, while a human eye is 5 to 6 times powerful than the best of the best cameras what we have. Which means, imagine you are seeing a colored image and you are trying to feed in that particular thing what a human eye is seeing. Now you go ahead and do your homework, how much of computational power your brain is able to do. We don't realize, but the brain is doing so much of computation, and when we try to replicate, we get the usual challenge. That's where we use the approach of convolutional neural network, which means it is not a fully connected neural network. It is a connected network as required, which means every neuron will not connect to every other proceeding neuron. So in case of CNN, the neuron in the layer will only be connected to a small region of the layer before it, instead of all neurons in a fully connected neural network manner. That does not happen. See this. Now, if you see this neuron, ideally in a fully connected network, it should have got connected to this should have got connect, or rather, this should have got connected to this, but that does not happen. Now this got connected to only this got connected to this and this, while this got connected to this and this got connected to this. So this way we try to reduce the requirement of computation by reducing the connections. Therefore, the computing power what you need will also come down significantly. That is the whole agenda of your convolutional neural network. The whole phenomenon works on this simple concept where we try to reduce the interconnectivity, or we don't use the fully connected approach in a convolutional neural network. That way we get to do the whole things and manage. Now if you go ahead and see what is your convolutional neural network. A convolutional neural network is a feed forward artificial neural network, or an ANN, in which the connectivity pattern between its neurons is inspired by organization in animal visual cortex. So in the brain we have something called as visual cortex. So many of you would have heard about color blindness. Some people are not able to identify the colors very well, or night blindness. They are not able to identify colors when it is dark or very limited light. All those implications are because of a deficiency in their visual cortex. So the visual cortex is a portion in the brain, especially in the backside of the brain, is a small region which is sensitive to specific regions of the visual field. Biologically, that is very, very, very powerful. Right? This was the whole motivation for us to devise a network on similar nodes. So if you read this, some individual neural cells in the brain responds, or what we call as a fire, only when presented to the edges of certain orientation. For example, some neurons fire when exposed to the vertical edges, and some when shown horizontal or diagonal edges, which means this is your object, this is your eye, and this is your visual cortex, which means the eye is the input layer which sends the signal to your brain, and brain is which assimilates, and visual within the visual cortex is what is helping you to infer. So now you understand a human being is a complex machine learning machine, I can say. Right? He has various inputs. His eyes is his input, his nose is his input, his touch is his input, his ears is his input. And many a times we try to do, when we are watching a TV, we are parallelly getting two inputs. One, the visual input, second one is the audio input, and it is in sync. Right? What we see, we try to hear, and we try to associate, saying whether we are seeing the right thing. The same things we are trying to replicate in the machine which we say convolutional neural network. So this is the crux or the core. And if anyone thinks artificial neural network, convolutional neural network are something man-made, I would say man copied. It's not man-made, it's man-copied, which means there was something which was existing. We try to replicate it in a machine. All right. So for that, definitely one major challenge we have tried to address is understanding the way human brain works. Like I said on the other day, probably the best of the best doctors in the world, not even in one geography, in the world, if I happen to say, the best neurosurgeons in the world also understand less than 5% of the brain's functionality. With whatever that 5% of understanding we have, we are trying to replicate using your machines. So that's the whole thing what you are doing in this entire approach of convolutional neural network. So how CNN works is something little interesting, and it gives you a lot of curiosity. Let's try to see this at a very, very high level, and we will repeat this to get the connectivity in our next session also. So if you see this, let me see 1 second. Okay, so if you see this, the convolutional networks have the following layers: a convolution layer, a ReLU layer, a pooling layer, and a fully connected layer. Now, if you see this particular images on the right side, left side and right side, the left side, you have a more modular or box like things, but as soon as you see this, your brain can easily tell this is something very close to your X, and this is very close to your O. But what you have forgotten is everything is a pixel. Pixel 1, pixel 2, pixel 3, pixel 4. This, if I ask you to replicate, you will write it like this, which means a simple X or a O can have so much of details at a pixel level like this. But now, when you have to use your CNN, let's see, and simple X can be written in various forms. Probably I have only taken a very, 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 very small thing, which is an X. This is an ideal case scenario. Ideally, I have written X with no complications. This is also an X. Your brain is telling easily this is an X, though it has multiple shapes. Same thing works like this. Though it is a distorted in the whole thing, your brain is still able to say this is X. Now, these three, at least to an extent, were okay. See this particular thing. And if I had not shown any of this, and I had shown only this, then also your brain is able to tell me this is X, which means the same alphabet can be written, or the same image can be available in various deformations. The same thing works for O. And biggest challenge what all of us, it's $1 billion question, whether it is a O or a 0. For a minute, if you park that $1 billion question and assume this is O, is this O, O is a big challenge. This is where we get to stop at an interesting point, how we converge this association of the letter, which is like this, with this, and say whether this is an X, this is an O, or something else. To solve such problems, we get our convolutional neural networks very, very, very handy. That is where you get to see things and make the whole approach. So what we will do is we will stop our session today here. We will see in our tomorrow session how exactly we break the ice, get this into a working mode. I will show you the calculation, then I will show you how exactly we can go ahead, put it into a Python code, try to see the same thing. When I say a 200 cross 200 image, or mm, 300 into 300 pixel image, how exactly it works, we will see that particular thing. So I think the attendance link is posted, so you can all mark your attendance. But any questions if you have, I am open for that before we close our session today. Any questions with regard to data transformation, data processing, the basic understanding of fully connected network? Oh, okay. So I don't see any questions. So let's again connect tomorrow and we will continue with this topic of convolutional neural network and get going. Okay. Okay. Thanks. Thanks everyone. Thanks for your time. Take care.